Okay, so it's time to look at some examples. All right, so if I want to expand quantity, x plus 1 raised to the fifth power, I could do that. Now, there are a number of ways I could do that. The really, really slow way would be to take x plus 1 and write it out 5 times. This would be terribly slow. And I would first multiply x plus 1 times x plus 1. Then I would take that answer and multiply by x plus 1 again and again and again. It would be very slow, and there's a pretty good chance that you would make a mistake somewhere in that process because it would be such a long process. A better way to do it would be to remember, the coefficients, okay? I have 5 bins, okay? Each one has an X and a 1. So I could take the combination of 5 things where first I'll count up how many X's I'm picking. I'm taking 5 X's and no 1s, plus the combination where I pick 4 X's, so that would be X to the 4th, and 1 factor of 1, plus the combination of 5 things where I choose 3 for the 3 X's, and 1 has to get squared, plus the combination of 5 things where I take 2 of the X's, and then 1 will be cubed, plus the combination of 5 things chosen where I choose 1 of the X's, and then I have 1 to the 5th, which obviously is just 1, plus the combination where I have 5 things and I choose no X's, so that would just leave me with 1. Oh, I'm sorry, that was 1 to the 4th in the last example. It wouldn't matter, but that was 1 to the 4th in the last term, and now 1 to the 5th. You probably, you can figure out those combinations relatively easily, so you would probably end up getting the right answer, but it would take a while. The fastest way to do this is to just quickly spit out Pascal's triangle. Okay, so let me do this in blue. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And I know that the degree 5 from this, remember we started at degree 0. And this is degree 1 and degree 2 and so on. The degree matches the second number. So I know by the time the second number gets to 5, I have reached degree 5. So I don't have to actually count the rows. I know this is the row that I want. Okay, and remember I was expanding x plus 1 to the 5th. So I can take my first coefficient, which is 1, which I don't need to write, and I will use that. That is what the combination of 5 objects, taken 5 at a time, would be. Okay, and then the second coefficient is a 5, which is the same as C 5 comma 4. So we don't have to compute it out. We have it there in Pascal's triangle. We take one of the factors of x away and add a factor of 1. Plus, then we have 10 as the next coefficient. We take one factor of x away and add a factor of 1. Then we have another 10, and we will take 2 factors of x. We take one factor away and add a factor of 1. And then we have a 5. We're down to 1 factor of x and 4 factors of 1. And then finally, we have 1 times 5 factors of 1. Now, it's just cleaner not to write in the 1s to any power. So this is x to the 5th plus 5x to the 4th plus 10x cubed plus 10x squared plus 5x plus 1. And we could box that in. That is our answer. Okay, so you can see how using Pascal's triangle, we get there rather quickly. Let's do another example of this. Let's say we wanted to, that was example 1. Example 2, we want to expand x minus 3. And we're going to expand that to the 4th power, right? Well, we don't need, we have a Pascal's triangle right here. We could just pull off the 4th degree row there. So it's the 1, 4, 6, 4, 1 row. And we have 1 as the coefficient of x to the 4th. So when we choose all 4 factors to be x, we can only do that one way. But if we choose, there are 4 ways, that's where the 4 comes from, to choose 3 factors of x and 1 factor. Now be careful, this is of -3. And then there are 6 ways to choose 2 factors of x and 2 factors of -3. And then there are 4 ways to choose 1 factor of x and 3 factors of -3. And then finally, there's 1 way to choose no factors of x, but 4 factors of -3. Now, we need to be careful in the simplifying of things. When we have odd factors of -3, we're going to get negative answers. So in those 2 terms, we should get negative answers, the 2nd and 4th term. But when we have even factors of -3, we will end up with positive answers. So just be careful when we're simplifying this. So this is x to the 4th. Now we'll have -12x cubed plus, and then we have 9 times 6. Remember to square that 3. So that's 54x squared. Then it will be a negative term. And that's 27 times 4. So that is 80 and 28. So 108 factors of x. And then finally, it will be a positive term, and 3 to the 4th is the same as 9 squared, so that is 81. So that is our answer. So example 3, this will be an easy one. Let's just do x plus y. Let's go to the 4th power again. This is easier than the example we just did because it's 1x to the 4th plus 4. We drop x1 and bring y up 1. The next coefficient was a 6. And that's how many ways we can choose 2 x's and 2 y's. And then there are 4 ways to choose 1 x and 3 y's. And then finally, there's only 1 way to choose all y's. And there's no way to simplify this. So this is the best form of the answer. Now let's end with one that's a bit more complicated, but not terribly so. We just have to keep track of things carefully. Let's do 2x minus y squared. And we're going to take that to the 3rd power. So just quickly, I'll do Pascal's triangle since it's off the screen now. I'm just going to draw it again. I only need to go to the 3rd power, 1st power, 2nd power, 3rd power. So the coefficients will be 1, 3, 3, and 1. Now the factors, though, are 2x, and then be careful, it's negative y squared. Those are the 2 factors that we're working with. So if we were to take 2x all 3 times, there's only 1 way to take that factor 3 times. There are 3 ways to take the first factor twice and the second factor once. And there are 3 ways to take the first factor once and the second factor twice. And then there's 1 way to take the second factor all 4 times. I should be saying term all 4 times. There's the first and second term of the binomial. So we're going to count them as factors. So I muddled my language a little bit. So we can simplify this now. This is not in the best form. Be very careful, though, when simplifying. When you cube 2x, people usually, or often, I should say, forget to cube the 2 as well as the x. So a very common mistake is to say that's 2x cubed, which it is not. It's 2x times 2x times 2x. Same thing here. Remember to square the 2 and the x, all right? And then we have, once again, then we have to look out for negative terms. This term will be negative. It's not negative y being squared. It's the negative of y squared. And then that will happen once. So that will be a negative thing. Oh, and I messed up. We never had 4 factors of y squared. It was 3 of them. That should have been a cubed. So this will also be a negative term. So we'll go plus, minus, plus, minus. So let me change this to a minus. Okay, now, as I was saying, remember to square the 2. So we'll have 12 as the constant. 3 times 2 squared. We have 2 factors of x. Now be careful, we do have a negative, which we already brought to the front for the negative y squared, but that's a y squared there. Okay, and then we've already determined this term will be positive. We have a 3 and a 2 to get a 6. We only have 1 factor of x left, but we're squaring y squared, so we have y to the 4th. And then finally, we have a negative term again. It's y squared getting cubed, so that would give me a total of y to the 6th. So this is just a bit trickier when you expand it, and I highly recommend, if you see what I did here, I took the terms and I subbed them in parentheses so that I could just put the coefficients in and the terms to the proper powers without worrying about too many things all at once. So I put the terms in parentheses and raised them to the proper powers. And then I did, the mathematics of each individual term.